Okay, folks, Unit 2 exponents review. Let's get to this. Number 1, exponents of 0 and 1. Evaluate. So let's get started here. 5 to the 0. 5 to the exponent 0. Remember, anything to the 0 exponent is just 1. So 5 to the 0 is 1. 17 to the 1. Anything to the 1 is just the number itself. That's 17. Negative 17 to the 1. Remember, the question you have to ask yourself is, what is the exponent attached to? It's attached to the number only. It's not attached to that negative sign or the negative 1. So it's just negative 17. In brackets, negative 17 all raised to the exponent 1. So this time, it's raised to the entire negative and the 17. So that's just negative 17. Alright, negative 5 to the 0. We said anything raised to the 0 exponent is 1. But remember that 0 is only attached to the 5. It's not attached to the negative sign. So that's just negative 1. Negative 5 to the 0. This time the 0 is attached to the entire negative 5. So that is just 1. Negative brackets, negative 5 to the 0. So that's negative 1. And that's just negative 1. Okay. And this one is negative, and then brackets to the 0 exponent, and that is just negative 1. Okay, there we go. Product rule, product rule, evaluate. So b squared times b to the 4th. Remember, when you're multiplying terms where the base is the same, you add the exponent. So that's b to the 2 plus 4 exponent, and that's b to the 6th. We have the same base again, negative 3 and negative 3, so that's negative 3, and we're just adding the exponents, 4 plus 5, and that is negative 3 to the exponent 9. Same thing, we have the same base, so that's 2 to the 2x plus 4x. Use this, follow the same rule, so that's 2 to the 6x. 3a to the 4th b times 5ab to the negative 2. So 3 times 5 is 15. Let's take care of the a's first. So a to the 4th times a to the 1. That's a to the 5th. B to the 1 times b to the negative 2. So that's b to the 1 plus negative 2. And that's b to the negative 1. Okay? That is the product rule. Quotient rule. If you have the same base, so we have the same base of b and same base of b, and we're dividing, you simply subtract the exponent. So we keep the same base, that's b, and say 12 minus 5, and that is b to the exponent 7. Same base of x, so we rewrite it as x, and we say 6 minus 2, that's x to the exponent 4. Here we have the same base of 4/3, so that's 4/3 to the exponent 6 minus 2, and that equals 4/3 to the 4th. Here we have a lot more going on, so this is an exercise in keeping all your values straight. So we have x's and y's and z's on the numerator and the denominator, so let's rewrite it as x, 7 minus 2, y, 3 minus 1, and z, 4 minus 4. So that's x to the 5, y squared, and that's z to the 0. And we can simplify that even more. That's x to the 5th, y squared, and z to the 0 is just 1. So we'll just leave it as x to the 5th, y squared. One last one, so that's 3 halves m to the negative 1 minus negative 3. So let's keep these negatives straight. And n to the negative 4 minus 3. Okay, stay with me here. That's 3 halves. Negative 1 minus negative 3, that's negative 1 plus 3. That is 2, so that's m squared. Negative 4 minus 3 is negative 7, so that's n to the negative 7. So we have 3 halves m squared, n to the negative 7. That is quotient rule. Next page. Power rule, or the power of power rule. power of exponents. So also the brackets rule, evaluate. So when we have a power, we have an exponent of an exponent, we multiply the exponent. So that's the rule. So that's 2 to the 3 times 4, and that's 2 to the 12th. M to the 2 times 7, that's m to the 14th. Okay, so we have a division problem here. We still follow the same rule. You do it for the numerator and the denominator. So this becomes m to the 2 times 5 over n to the 3 times 5, and that equals m to the 10 over n to the 15. Okay, here we can apply the power rule, but let's save yourself some work. Simplify what's inside the brackets first. So we have x to the 8 times x to the 4th. We know that's x to the 12 divided by x to the 3rd. And don't forget, it's all raised to the exponent 2. We can still simplify inside the brackets. X to the 12 divided by x to the 3rd is x to the 9th, and it's still raised to the exponent 2. And that's x to the 9 times 2 equals x to the 18th. Alright, brackets 3x to the 3rd versus 3 times x to the 3rd. How does that differ? So that's 3 to the 3rd times x to the 3rd. And that is 27x to the 3rd versus 3 times x to the 3rd. So you see brackets, and what the exponent is applied to or attached to makes a huge difference. Okay, so be mindful of that. All right, a bit more complex problem here. Let's work across. So that's negative 3 cubed. Remember, that's in brackets. Y to the 6th times negative x squared y cubed times 2x. So that is negative 27 y to the 6th negative x squared y cubed 2x. Just want to do one step at a time. Now let's combine everything. So that's negative 27. Let's do the x's first. That negative on the x will make this positive. It's like saying a negative and negative is positive, so we've taken care of that. What about the x's? So x squared and x over here, that is x to the 3rd. Actually, you know what? Let me back up here. I don't want to confuse you all, so I'm going to start this over, and let me just make sure I do this the correct way. Okay, so let's expand this first. That's negative 27 y to the 6th. Okay, negative 3 cubed is negative 27, y to the 6th, y to the 2 times 3 is y to the 6th, negative x squared y cubed 2x. So it's important that you apply that exponent first instead of multiplying that negative 3 across, because you have to apply that exponent. Okay, so let's take care of the constant first. So we have a negative 27 and a negative 1 here in front of this x squared, and we have that 2. So negative 27 times 2 is negative 54, times negative 1 is positive 54. So we have 54. And then now let's take care of the variables. We have x. We have an x squared here and an x to the 1. Remember, you can say that's 1. So that's x to the 3rd. And then what do we have for the y's? Y to the 6th and y to the 3rd. That's y to the 9th. So we have 54x cubed, y to the 9th. So sorry about that. This is a much easier way to explain that. Okay? All right. Moving along, combining exponent laws. So this is a problem that combines all the exponent laws to test your knowledge of whether you can apply them correctly. So here, let us simplify what's inside the brackets first. So you can see there's lots going on there. So that's c to the 3rd, d to the 5th over c to the 7th. So that is d to the 5th. Oops. That is c to the negative 4, d to the 5th, to the 4th, divided by d to the 11th, c squared d to the 5th. Okay, So here, c to the negative fourth, d to the fifth, we're going to apply that negative exponent rule. I know it's coming up, but let's do it this way. D to the fifth over c to the fourth. So we're applying that flipping rule, all to the fourth divided by d to the 11th over c squared d to the fifth. So let's apply the power rule. So that's d to the 20th over c to the 16th. And that's divided by d to the 11th over c squared d to the 5th. So when we are dividing fractions, so we're essentially dividing fractions here. Remember the leave me, change me, flip me over. So leave me part is d to the 20th over c to the 16th. Change me is the division sign is into a multiplication sign, and flip that last term. So that's c squared d to the 5th over d to the 11th. Let's write this all in, actually let's put it all in one fraction. So that's d to the 20th times c squared times d to the 5th, all over c to the 16 times d to the 11th. Let's simplify the numerator first, at d to the 20th, so that's d to the 20 plus 5, using the product rule, so that's d to the 25. And c squared, and what's in the denominator, that's d to the 11th, c to the 16th. Now we can apply the quotient rule, so that's d to the 25 minus 11 is d to the 14th, and c to the 2 minus 16th is c to the minus 14th. And let's leave no negative exponents, so that's d to the 14th over c to the 14th. Okay, there we go. Negative exponents, evaluate. So a to the negative 6 is just 1 over a to the 6th. So you flip it over and make the exponent positive. 2 to the negative third is 1 over 2 to the third, which is 1/8. Okay, flip it over, make the exponent positive. Here, 2/3 to the negative fourth, you can flip what's inside the brackets and make the exponent positive. Okay, so that's 3/2 to the fourth. Or another way to look at this is 1 over 2/3 to the fourth. So here we know this is 3 to the fourth over 2 to the fourth. That's 81/16. Okay, 81/16. 1 over 2/3 to the fourth. That is 1 over 16 over 81. And we know that is 81 over 16. So it's the same thing. Okay, that's just two different ways to look at this. Okay, this versus that. Brackets 3x to the negative third versus 3 times x to the negative third. So mind your brackets and what is the exponent attached to. Always ask that question. What is the exponent attached to? So this is 1 over 3x brackets all to the third. Because that exponent is attached to the everything that's inside the bracket. So that's 1 over 27x to the third versus 3 over x to the third. Okay, and these two are clearly different because the brackets change the values of each. Okay, so mind your brackets and ask yourself the question, what is the exponent attached to? Okay, 14a to the negative fifth divided by, in the bracket, 7a times 2a to the negative fourth. So let's do this. 4a to the negative fifth divided by, let's simplify what's in the brackets. That's 14a to the negative 3. Okay? 14a to the negative fifth divided by 14a to the negative third. I'm going to turn this into a fraction. So 14a to the negative fifth, when you're dividing, it's like doing a fraction like this. 14a to the negative third, okay? Shouldn't look like magic, but that's what it is, okay? So let's pause and think about that. So 14a to the negative fifth divided by 14a to the negative third. Let's put it in fraction form. Makes it much easier for me to work through. 14's cancel here. So we're left with a to the negative 5 over a to the negative 3. And that is a to the negative 5 minus negative 3. Okay, careful with your negatives, applying the quotient rule. That's a to the negative 5 plus 3, that's a to the negative 2, and that's 1 over a squared if we're asking you to leave it in terms of positive exponents. There you go. A couple other useful rules to remember. Remember, x plus y, the quantity squared. So x plus y in brackets squared does not equal x squared plus y squared. You cannot distribute that exponent across a plus sign. Also, you can't go across a negative sign or a subtraction sign either. So x plus y squared, what we know about, so that's not true. So what we do know about exponents, it's repeated multiplication. So that is equal to x plus y times x plus y. And we'll see in our polynomials review what this actually equals. Some of you may already remember use the FOIL to multiply all of this together, okay? But we'll leave that for polynomials. Do not distribute exponents across an addition or negative sign, okay? Don't do that. Okay, scientific notation. Rounding and scientific notation. So round 2.832 to the nearest hundredth place, 2 decimal places. So here is the 100th place. Look at the number to the right. If it's less than 5, you drop the number and add a bunch of zeros, and you keep that place the same. So here it's 2.83 and 000, right? But essentially it's just 2.83. Okay, right? 143491231. So that's 143,491,231 in scientific notation, 3 decimal places. So we start here. Where's the decimal? Right here. How many places? 1, 2, 3, 4, 5, 6, 7, 8 places. So note that, 8 places. We said 3 decimal places, so 1.43. So is it 4 or is it 5? Look at the next number to the right. It's a 9. It's greater than 5, so you have to round up. So it's 1.435 times 10 to the positive 8 because we went to the left, okay? 1.435 times 10 to the 8th. Last one, 0.0569 in scientific notation to the nearest thousandth place. So the thousandth place, okay? Decimal point, 2 places, so remember that, 2 places. And we have 5.69. Oh, actually, there's no the thousandths place. We can add that 0, tens, hundred, thousands. So it's 5.690 times 10 to the, this time it's a negative 2 since we're moving to the right. Okay, there you go. Match the equivalent expressions. This is further testing your knowledge of exponents and what the exponents are attached to and brackets and negative signs. Okay, this is a good exercise in keeping all your rules straight. Okay, so let's take a look here. Negative 3x in brackets to the negative 2. Let's work this out. So that's negative 1 over negative 3x in brackets squared. So that's 1 over 9x squared. And which one is that? 1 over 9x squared. There it is. And that's letter F. 3x to the negative 2. That negative 2 is only attached to the x, folks. It's not attached to the 3. Okay, so this one is 3 divided by, or 3 over x to the 2, and that's as far as we can go. And 3 over x to the 2, where is it? It's right there, so that's letter B. Okay, negative 3x in brackets squared. That exponent is attached to everything inside the bracket, so let's work that out. So if we're expanding that, we can say that's negative 3 times negative 3 times x times x. Okay, you can write it out in expanded notation like that. That's 9x squared. And which one is that? There we go, letter D. Negative, in brackets, 3x to the negative 2 exponent. Okay, mind your negatives, mind where the exponent is attached to. So it's not attached to that first negative sign right there, so we leave that up top, negative 1, and we flip over everything that the negative exponent is attached to, and keep your brackets straight. So it's 3x squared. Right? When we flip, we change the negative exponent to a positive. And let's simplify that. That's negative 1 over 9x squared. We have a negative 1 over 9x squared. Let's take a look. There it is, negative 1 over 9x squared. And that is letter E. Okay, almost to the finish line. Stay with me here. Negative, in brackets, 3x squared. Okay, that negative sign is outside the brackets, and the exponent is only attached to what's inside the brackets. Okay, so keep that negative sign there. And if you write it in expanded notation, it's 3 times 3 times x times x. If it helps you to see it, do this. So that's negative 9x squared. We have a negative 9x squared. There it is, letter C. All right, let's work this final one out. Negative 3x to the negative 2. That negative 2, ask yourself the question, what is it attached to? It's attached to the x. So leave that negative 3 alone. That negative 2 exponent is not attached to the negative 3, so we don't flip it. Negative 3 over x squared. Do we have a negative 3 over x squared in the house? And there it is, folks. Letter A. Okay? So be able to do a problem like this. This is a good problem to understand so you know how to apply the various exponent rules and the flipping and the negative signs and what the exponent applies to. All right?